So the selection of what? Drill bits will depend upon strength of your rock mass. How about in hydraulic design? What's the significance of your 3D model in in hydraulic design? Design of underground and surface drainage structures. What? Dredging. That's part of excavation. But I'm particularly interested in hydraulic design. What's the significance of 3D model in your hydraulic design? Remember, you have several structures in your what? Model, right? And structures are passageway of what? Fluids. If your rock mass is ramified by a lot of what? A lot of joints with very long strike and deep persistence, and therefore, what can you expect? Matubig, di ba? Matubig. So appropriate hydraulic, surface and underground hydraulic structure should be what? Installed. Because this can affect your operation. Can you follow? And this can likewise affect the stability of your pit and the stability of your underground opening. Pag laging basa, mahina yung friction angle, mahina yung shear strength. Naintindihan? In order to stabilize your tunnel and likewise your pit, you have to what? You have to implement an extensive and a continuing what? Dewatering program. Can you follow? So you have to effectively release both surface and subsurface water away from your what? Your pit and away from your tunnels. Right? And that's the very reason why you have hydrology also. Hydrogeology in your curriculum. Can you follow? Hydrogeology and hydraulics, no, are related to each other. Did you get it? Hydraulics is more on what? Surface water. Hydrogeology is more what? Encompasses both surface and what? Subsurface water. Did you get it? How about in metallurgy? What's the significance of your 3D model in metallurgy? Sabihin ng metallurgist sa'yo, what is that to me? Sabihin ng materials engineer sa'yo, what is that to me? Oh. Pag silicious yung ore mo, di ba? Matigas yun. Gagamit ka ng crusher, di ba? Crusher saka ng grinder. So it will affect the design of what? Yung crusher mo saka yung grinding. Did you get it? Parang drill bit. Pag matigas yung bato, gumamit ka ng yung durable saka mamahaling crusher. Right? Just imagine ika-crush mo yung silica. Kung yung ore mo is siliceous, right? Most of the gold ore are what? Siliceous. Porphyry copper deposits are likewise what? Silica altered. Did you get it? Silica acts as a gum. And you follow, if your target ore is either copper, chalcopyrite, or what? Say, gold and silver tellurides. And you follow, even free gold. So you have to liberate gold and copper from your what? Siliceous ore. And to liberate them, you have to crush it and grind it. So it will affect the selection of what? Crusher and grinder. So malaking implication yan, ha? Can you follow? Yes. So ang guide ngayon, ng minero, ng metallurgist, ng mine engineer, ng civil engineer, at a lot of civil engineers are involved in mining in Australia and Canada. Yung model mo. Can you follow? So you may be able to estimate the cost of what? Production, cost of operation, and cost of everything, okay, using your 3D model. So from time to time, there is a need to calibrate your model, especially if you do infill sampling. You can further calibrate it and validate it to allow to ensure that your model simulates near virtual reality. Did you get it? Yung virtual reality is the in situ engineering, okay, property of your ore, including that of your surrounding counter. Considering that your data is limited, what you can generate is just a model which simulates near virtual reality. Did you get it? Okay? And this will be calibrated as you continuously obtain data during the course of mining or extraction. So is there any question regarding this? So that's the complete answer to question number 1. Okay, anybody here got a perfect score for question number 1?
Sayang.
Huh?
Sayang, lapit eh. Lapit.
Mining methods.
Lapit daw.
Di ba, even in the selection of di ba, underground mining method, you need a 3D model. Di ba? Renescent pa yung 3D rock modeling eh. Okay?
Sayang.
How about in the selection of underground mining method? So that's your core specimen, right? Oh yan, hindi ko na nga tinanong yan eh. Dapat, tatanong ko rin yan. Kaya lang, medyo high level na kasi computer application in geology, right? So, what are the criteria used in the selection of underground mining method? The first criteria is shape. Ba? Okay. Whether your ore is regular. What is a regular ore? A regular ore has a uniform dip, uniform thickness, right? And it's not structurally controlled. Diba? How about an irregular ore? An irregular ore has a variable dip and a variable thickness, but not structurally controlled. How about tectonized? Vein that has been, it's a vein or what? An ore which had been what? Displaced by what? Faulting. So tectonized done. So that's the first criteria. You eliminate based on what? Shape. Right? But you have to mention shape. Whether shape is regular, irregular, or what? Tectonized. Thickness. Just mention thickness. You don't have to mention 1 to 3. Plunge. Right? What else? And what? And your geotechnical
Requirements.
Requirements. Rock mass rating and what? Q system. That's all. And another thing is what? Stress, di ba? Meron pang stress. Ayan, stress. Diba? Okay, kung high stress ka, low stress environment, or what? Intermediate stress. Okay. Oh, yun ang sagot. O, sino naka-perfect? Kasi nag-aaral eh.
So, lapit na.
What? Pag nadaplisan ka, ibig sabihin 90 ka, Melvin. Baka ikaw nadaplisan, no? hindi ikaw nakadaplis. Okay? O, may tanong. O, naintindihan niyo na. Pag hindi kasi ako magbibigyan ng exam, hindi magsisink eh. What? Hindi, RMR is rock mass rating. MRMR is modified rock mass rating. What? Oh, pareho silang design criteria.
Ay, may ganun tayo, di ba?
Saan na ba? Dali lang, hinahanap ko pa yung wala yung lecture. Sinong gustong kumanta? Commercial muna.
Sige.
Bookstore na kinabang sa akin.
Lapit ko na ito.
So that's blasting, eh? We'll discuss details about this.
Wow.
Walang sounds na. Sounds. We'll discuss this later. Di ba? Nawala. Speaker ba yan? Slide niya si Jeba. Slide niya si Jeba. Slide. Parang king sa ugon. Yun yung brown eh.